This video I will show you this 3D model of the unit coordinate system that I've created using the software of Onshape, and this will allow us to find out matrices, to verify the values that we get in our matrices by using geometric representation. So here what you have to do first is to convert this unit coordinate system that is fixed. Right click on this and choose make transparent. That will make it transparent. When you click on this and apply some rotations on it, you can see that the transparent coordinate system, which is fixed, it's appearing in the background, and we have another coordinate system that is kind of here. So the rotation of this coordinate system with respect to the previous one, that is the fixed one, that is appearing here in transparent color, that's what we aim to find. Now here in the configurations, I have made a setting which allows you to choose rotation about X, Y, or Z axis. So you can choose whichever rotation you want to choose. So let's go with rotation about X axis first. When you do that, you can see here that rotation of X axis gets unsuppressed. If you click on this, you will get the angle value here. You can change that angle value. So let's say we are giving it a positive angle of 30 degrees. Positive angle of 30 degrees. Then the matrix that you get will have 3 columns, and the 3 columns are actually the coordinates of these endpoints. So the first column will be the coordinates of X axis. So after getting it, you can just click on this button over here, measurement column, and you'll be able to verify what are the coordinates, the 3 coordinates that you are getting over here. So coordinates of X, if I want, you just have to click on this bulb over here. You can see here you'll get the coordinates of X. If you want to make rotation of Y axis, just choose axis. Again, click on this and change the angle to whatever you want. And yeah, so when you feed this 30 degrees into the matrix, you will get a 3 by 3 matrix. Again, once again, you will be able to find the coordinates of all these values by clicking on this. Okay. So because now we are making rotation of y-axis, the x coordinates will be this, rotate it 0 and negative. Then the second column will be the coordinates of y-axis, which is 0, 1, 0. Then third column will be the coordinates of z point, and that will be 0.5, 0, 0.866. So whatever angles you want to rotate it, and about whatever axis you want to make that rotation, that is all possible over here. So just choose whatever axis you want to make rotation of, and then choose whatever angle you want to give it, and just click on the sphere, and you will get all the coordinates measurements. So this will also help you in finding the coordinates after doing a number of rotations about composite axis. For that purpose, we'll have to first reset this to 0. Then we'll have to actually go for composite rotations, and after clicking on that, we'll have to select whichever axis we want to rotate it about. Let's say, for example, we want to first make rotation about X axis. So just click on that, then give the rotation. Okay, and here you can set whatever angle you want to rotate it to. Let's say 30 degrees. And then next, let us say I want to rotate it about the changed Z axis. So let's try that you just click on the Z axis, and this way you will get this thing. And you can see here there is an option for me to rotate it about Z axis. It's not rotating about X, about the Z axis, the changed Z axis. So again, I can feed whatever angle I want, press enter, and now it has undergone 2 rotations in Euler rotations. The first rotation was about X axis, and second rotation was about the changed Z axis. So when you multiply these 2 rotation matrices, you will get a single composite matrix, which defines the orientation of this unit coordinate system. And you can verify the result that you get in that composite matrix by clicking on these 3 points. So let's go ahead and do that. So when I click here, we'll get the first column of the 3 values. It's 0.707, 0.612, and 354. The second column coordinates will be here, negative 0.707, 0.612, and 0.354. And the third column is going to be here, 0, minus 0.5, and 0.866. So these are the coordinates that we're getting after performing 2 Euler rotations. You can continue to do a number of rotations next if you want to rotate about y-axis. Again, we want positive or negative rotation depending on that. This is the positive rotation. So let me rotate it by 60 degrees. And yeah, so now I have now this coordinate system has undergone 3 Euler rotations, and at the end of this, whatever coordinates we get, we can just verify them by clicking on this. So this is the x coordinate first column, these are the y coordinates second column, this the third column coordinates of z. So hope this this model will be helpful to you in verifying whatever angles angular rotations you want to make, and help you understand how this orientation are represented in with the help of these rotation matrices as well as with 3D. Thank you.